Today, we are going to learn how to graph a function with its inverse, especially its inverse. So I'll start with a basic definition of an inverse. An inverse, which is written f to the negative 1 power, is when you switch the x and y values around. For instance, if f of x is 3 comma 0, 5 comma 10, negative 2 comma 3, and negative 8 comma 2, then its inverse function would be when we switch those values around. So it would be the set of ordered pairs 0 comma 3, 10 comma 5, 3 comma negative 2, and 2 comma negative 8. And we know that that's a function because none of the x values repeat. So we're going to take that a step further. We're going to graph the parabola 4 times the quantity x minus 2, quantity squared minus 5, and then we're going to graph its inverse. The parabola 4 times the quantity x minus 2 squared minus 5 is the parabola with a vertex of 2 comma negative 5 because that minus 2 means we move to the right 2 and the minus 5 means we move down 5. And the 4 means that our parabola is going to be quite thin. And as an approximation, you could go up 4 over 1 in both directions. And you could know that's about as thin as the parabola is going to be. Okay, but the part that we really want to concentrate on today is its inverse. How you graph an inverse, even without knowing what the function's equation is you just take these ordered pairs and you switch the x and y values. So instead of the vertex being 2 comma negative 5, the vertex of my inverse is going to be negative 5 comma 2 because I'm switching my x and y values around. In the first function, I have found the ordered pair 1 comma negative 1. If you put 1 in for x, 1 minus 2 is negative 1 squared is 1 times 4 is 4 minus 5, you get negative 1. So yes, 1 comma negative 1 is an ordered pair, just like 3 comma negative 1. If you were to put 3 in that quantity for x, you would get the ordered pair 3 comma negative 1. So if you take those two ordered pairs and you switch them around, you now have negative 1 comma 1 and you have negative 1 comma 3. And you can graph the inverse of that first parabola. An inverse should always reflect over the line y equals x, because when you switch your x and y values, it is always going to be symmetric over the line y equals x. And if you look at those two, if you were to fold this paper in half, you would see that they would line up on each other. Okay. Of course, the next question would be, is this green inverse a function? And of course, it's not a function because a vertical line is passing through 2 points. So yes, you can graph its inverse, but the inverse is not a function. So let's try that one more time. Let's take a cubed equation and graph it, and then graph its inverse. Okay? Since this is a plus 4, we know that the inflection point is left 4, so negative 4. And then since it's a plus 2, it'll be positive 2. So negative 4 comma 2 is the inflection point of my cubic equation. We also know that this cubic equation is going to go down to the right instead of up to the right because of our negative coefficient. So I am just going to sketch, and that's not perfect, but sketch a cubic equation going down to the right. Now, to graph its inverse, which is the point that we're trying to make, is you're switching these x and y values. So the point -4 comma 2 is now going to go to the point 2 comma -4. In the first function, if you were to put -3 in there, -3 plus 4 is 1, cubed is 1, times -1 is -1, plus 2 is 1. So -3 comma +1 is a point. Just like if I were to put -5 in, I would get a +3. Well, to graph its inverse, we switch those ordered pairs around. So 3 comma -5 and 1 comma -3. Some people are still not sure which way this cube is going. It might even look like it's linear at this point. So that's where I just start approximating. And you can be much more exact than this, but just approximate something on its tail. Okay, like here, it's going to go down to the right. So let's just approximate. -1 comma looks like a -7. I could be exact and put it in, but I'm not going to. So it looks like it's around -1, -7, which means if I were to do its inverse, that would be -7 comma -1, which shows you that this tail is going to the left. All right? And you could do a point on the other tail, like this was -5 comma 3, so we could say -6 comma something up there. -6 comma 10 might look like it. Again, I could put it in and be exact, but if I'm just coming up with a sketch, then I'm going to go 10 comma -6, and I can see that that's going to the right. So my cubic inverse is going to go right and left rather than up and down. And again, if you were to draw them really nicely, they would always reflect over the line y equals x, which it kind of does. I'm not a perfect drawer by any means. And that's how you graph an inverse. You graph the first main equation, and then you flip the x and y values around and graph its inverse. And then your last question would be, is this a function? Well, yes. Any vertical line that I would happen to draw here would not have more than one point in it. So yes, this would be a function.